Welcome to The Explainer. Today, we're opening up a case file on a really strange problem at the very heart of science itself. A mystery where major, landmark findings just seem to vanish when other scientists try to check the work. So let's investigate. What is going on here? And why does it matter to all of us? Our investigation kicks off with this one single, really startling piece of evidence. So back in 2016, a review looked at studies in one major scientific journal and found that a staggering 84% of all the hypotheses were confirmed. Now you might think, wow, that's a great success rate. But in the world of science, that is a huge red flag. It's almost too good to be true. And it's our first big clue that something is fundamentally wrong with the system. All right, to get to the bottom of this whole thing, we're going to follow a pretty clear path. First, we'll examine the crime scene. What is this replication crisis? Then, we're going to identify our prime suspect and their methods. After that, we'll look at how we can actually fix the system. And finally, we'll deliver a verdict on a system that really seems to be on trial. So let's start at the crime scene. Let's dig into the evidence and really try to understand the scale of this replication crisis. Okay, the core of the problem is actually shockingly simple. You have all these scientific findings, and when other scientists try to retest them, they just don't hold up. A discovery gets made, it's published in some big, prestigious journal, but then another team comes along, follows the exact same recipe, and they get a completely different result. The original finding, it turns out, was like a ghost. Now, to really get this, we need to know the difference between two key terms here. First, there's reproducibility. That's just the baseline. Can someone take your original data and your code and get the same answer? But replicability, that's the real test. It asks, if I do your whole experiment over again with new data, will I get a similar result? When findings start failing both of these tests, well, the whole foundation of science starts to feel a little shaky. And you might be sitting there thinking, okay, so this is some academic squabble, who cares? But honestly, this is not just a debate for scientists in ivory towers. This has huge, real-world consequences for every single one of us. I mean, think about science like a giant skyscraper, where every new discovery is a new floor built on top of the last one. If that foundation is unstable, if you can't trust the results from the floor below, the whole structure is at risk. It wastes time, it wastes money, it erodes public trust, and worst of all, it can lead to really bad policies based on research that was just plain wrong. So if the crime here is unrepeatable results, then who or what is the culprit? Well, investigators don't think it's a single bad guy. Instead, they've identified a prime suspect, a widespread practice that kind of operates in the shadows of the scientific process. Now, the prime suspect has a very technical-sounding name, systematic capitalization on chance. Okay, what on earth does that mean? Basically, it's when researchers go on a kind of fishing expedition in their data. They run analysis after analysis, they tweak this variable, they remove that one. It's a messy trial and error process until, voila, by pure chance, they find a result that looks perfect and statistically significant. The problem? They almost never talk about that messy search in the final paper. And this brings us to the motive. And it's not usually about fraud or anything like that. It's about immense pressure. As one source put it, researchers are pushed to torture the data until they confess. They need their data to say something exciting, something clear-cut, and above all, something that can get published. And that pressure comes from this brutal mantra in academia, publish or perish. A scientist's entire career, their funding, their promotion, their job security, it all depends on getting articles published in top journals. And guess what those journals love? Clean, positive, shiny, statistically significant findings. They're not so interested in the messy, uncertain results. This whole system creates this powerful incentive to find a neat story, even if that story isn't the whole truth. Okay, so we have our suspect and their motive. Now let's examine the modus operandi, the specific methods people use to make that data confess. And these aren't necessarily illegal things. They're what you'd call questionable research practices that have just become disturbingly common. Our investigation has uncovered 5 common practices that, when you put them together, let researchers capitalize on chance and produce these results that look way more solid than they actually are. So let's break them down, one by one. All right. First up, what detectives found is that modern research gives scientists a huge number of choices or degrees of freedom in what they decide to measure and report. And all this flexibility, well, it can be a trap. Imagine you're studying what makes a company successful. You could measure firm performance in dozens of ways, right? profit, stock price, employee satisfaction, whatever. Now, let's say you measure 10 of them, and only one shows a significant link to your theory. You might be really tempted to only report that one, making your finding look super strong, while you conveniently forget to mention the other 9 that showed nothing. It's not exactly lying, but it's not the full story, is it? The next clue in our investigation has to do with this strategic and often really questionable use of something called control variables. These are supposed to help rule out other explanations for your results. Think of it like this. A researcher is testing if A causes B. The result isn't quite significant, so they start adding control variables like C, D, and E. Then they try taking D out, then they try a combination of C and F. They just keep messing with it until they find some magic combination of controls that makes the relationship between A and B look significant. It's like adding and removing suspects from a police lineup until you get the witness identification you were hoping for. Next up, we have outliers. These are those extreme data points that just don't fit the pattern, and they present another perfect opportunity for a researcher to subtly nudge the outcome of their study. Here's how it might play out. A researcher's result doesn't quite support their theory. They notice a couple of outliers. Removing them makes the result significant. Keeping them in doesn't. Now, this decision can be justified as data cleaning, but if it isn't reported transparently, nobody can ever know if the finding is real or just an artifact of that one choice. And now we come to maybe the most infamous practice on our list, a little something called p-hacking. This is all about the hunt for a statistical magic number, a p-value of less than 0.05. For decades, getting a p-value below 0.05 has been the golden ticket to getting published. And this creates this huge incentive to hack your way to that number. So you try one statistical test, you get 0.06. Close, but no cigar. You try another one, it's 0.08. You combine groups, you split them up. You keep trying different analyses until, aha, you get 0.049. You've crossed the line. This whole process turns the noble pursuit of scientific discovery into this frantic game of just getting below a completely arbitrary number. Our final practice is a clever one. It even has a memorable acronym, HARKing. And it stands for hypothesizing after the results are known. This is exactly like shooting an arrow at the side of a barn and then drawing a big target around where it landed, claiming you're a perfect marksman. A researcher is just digging through their data, they find some surprising correlation they never expected, and then they go back and rewrite the paper's introduction to present this total accident as if it was their brilliant, pre-planned hypothesis all along. It turns honest exploration into dishonest confirmation. So, when you take these 5 practices together, they paint a pretty troubling picture. They blur the line between rigorous testing and creative storytelling, and they force us to ask a really fundamental question about the research we rely on every day. Is the goal to find the truth, or is it just to find a story that sells? Now, after all that, it might sound like it's all doom and gloom, but it's not. Now that we've exposed the problem and the methods, let's look at how we can crack this case and actually restore some integrity to the scientific process. There are some very clear solutions. The solutions really all boil down to one central theme: transparency. It's pretty simple. For instance, instead of cherry-picking variables, researchers should have to report all the variables they considered. Instead of quietly removing outliers, they should disclose the rules they used and show the results with and without them. And to prevent HARKing, they can pre-register their hypotheses, basically committing to their target before they ever shoot the arrow. But here's the thing. Just asking individual researchers to change isn't enough when they're stuck in a broken system. The fix has to be system-wide. The journals themselves need to stop rewarding only the flashy, positive results and start valuing rigor and transparency. They can do this by publishing more replication studies, the very studies that check if findings are real. They can also use submission forms that force authors to be transparent about their methods and require them to upload all the messy details. All right, we've examined all the evidence. It is time to deliver the verdict. Who is really at fault for this replication crisis? Probably the most important finding from this entire investigation is this. This is not a story about a few bad apples. The vast majority of scientists are honest people trying to do good work. The evidence points overwhelmingly to a systemic issue. The real culprit is the set of pressures and incentives that are baked right into the scientific ecosystem. It's the university promotion systems that just count the number of publications, not their quality. It's the journals that create this crazy competition for just a few spots by chasing headline-grabbing results. And it's the training that hasn't prepared researchers for the temptations that come with big data and this intense pressure to publish. Ultimately, the solution is all about incentives. We have to fundamentally change the game so that the motivation not to do these things is greater than the motivation to do them. The rewards for careful, transparent, and honest science simply have to outweigh the rewards for finding a tidy story by torturing the data. And that leaves us with one final provocative thought. Science's replication crisis isn't actually a sign that science is broken. In a weird way, it's a sign that it's working. It's self-correcting. The real challenge now isn't fixing broken scientists, but reforming a broken system of incentives. So the question for all of us is, are we willing to make the really tough changes needed to ensure that the scientific knowledge we build for our future stands on a foundation of solid rock and not on sand?